So welcome, everybody, to this session about Hadoop in the cloud. My name is Omid Afnan. I'm a program manager in the Microsoft Big Data Platform team. We're responsible for both our internal in-company big data platforms that we use for things like our Bing search engine, as well as products like HD Insight, which we offer through Azure to the public for big data. So in my talk today, I'm going to try and cover a few different things. I know the title said architecture of solutions in the cloud, and I'm going to get to some customer cases of things that people are doing with our service. But to get to that, and based on some of the questions that I've heard in the booth in the last day, I'm going to start out by talking a little bit about why would you consider Hadoop in the cloud, very briefly. And then I think also talk a little bit about why you would trust Microsoft with giving you a cloud solution in the big data space. So I've called that, can Microsoft do Hadoop? A lot of people looked at our little penguin that says Microsoft loves Linux, loves Hadoop, and you have some question mark on your face. Is that really how Microsoft feels? Are we really committed to this? So I want to help you understand that we really are very committed to this space. And then I'll do a brief demo, because we like to keep things technical as much as possible, show you some of the developer tools, which is the area that I focus on, big data developer tools. And then we'll try and get to some customer cases as well. So why Hadoop in the cloud? I think I've been asked that question several times in the last day. So I think most of the people here are pretty familiar with the big data space. A lot of you have already started using Hadoop. So you're familiar with the fact that these three V's, the volume, the variety, and velocity of data, is a major problem in the big data space. So by definition, big data needs high amounts of compute, high amounts of storage. We heard in some of the keynotes yesterday talking about how can you unlock the compute power that you need to actually iterate over these big data sets that you're collecting. And additionally, Hadoop right now, and probably for the foreseeable future, is fairly complex technology for you to set up or for your group to set up and get that running. The cluster management is not trivial. Knowing what to install and how to keep up to date with the various distributions. These are not simple tasks, and sometimes they're barriers to entry. Of course, the cloud promises that we should have great speed and scalability, that you should be able to get that storage and that compute power that you need for something like big data. It also says that we should be able to give you better economics. It should actually be cheaper for you if you can get this big data solutions, Hadoop platform in the cloud, and hopefully only pay for what you use, only pay for the compute cycles that you use, only pay for the storage that you use. And particularly in the case of Hadoop, if we can remove for you the barrier around setup, around configuration, around deployment, that should be a really big win. And I think that we do that. So rather than you having to learn how to configure a Hadoop cluster, and then finding out tomorrow, next week, next month that really the 4 nodes is not enough, I need 8, I need 16, I need even more than that, and having to go back and acquire more hardware and do more changes to your system, we try and remove all of those barriers for you. So Hadoop in the cloud, whether it's Microsoft doing it or any other provider doing it, this is some of the core value proposition of why you would want to do that. Of course, you might have some questions, and I've had these questions asked. Is the performance as good or better? Is it reliable? Can I really count on having this happen? And I think when we get to the customer cases, some of the architectural patterns, you'll see that, yes, in fact, it's very doable. So why Microsoft Azure as your cloud platform for big data? So right now, Azure has been around for several years. This says more than 4 trillion objects in Azure. That's actually, I think, out of date. I saw something else today that was a factor of 10 bigger than that. It was saying 30 billion objects in Azure. But the point being that Azure, in terms of scalability, in terms of usage, has already proven itself and continues to do so every day. Our growth rates are quite high. We don't have them on this slide, but we have thousands of new users every week joining on to Azure. But more importantly, for the big data space, we have the boxes in blue are things that are Microsoft developed and onto Azure. So we have HD Insight, which I'm going to talk about a little bit more. We have machine learning libraries and tools. we have site search, we have event hubs, all kinds of things. Plus, we're not locking you into any of those things. We're saying you can also take all our partner offerings. So you'll see Cloudera and Hortonworks on there, and you can easily choose the stack that you want to deploy for Hadoop. You can even use services like Kubol, who are providing query services on top of Azure, on top of Hadoop. So there's really a lot of choice of what you can develop. And the other point that Microsoft is very strong about or insistent about is that Hadoop will not be, for most enterprises, a cloud-only solution. In fact, most of our enterprise solutions are not cloud-only. There's some kind of hybrid on-premises and cloud story for almost any large enterprise or even mid-sized enterprise we talk to. So we really try and support that very directly. So HD Insight, as hopefully you picked up through some of the keynote talks and other places, is Hadoop on Microsoft Azure. So it's Hadoop in the cloud. It's based on 100% open source Apache compatible Hadoop distribution, which our partners at Hortonworks provide. There's nothing, there's no secret piece that's different. There's no internal API that once you start using this, you're going to be locked into. It's pure Hadoop. And it can be up and running in minutes, and I'll show you that very briefly in a moment. And what we've done, though, is said that we do want to unlock the power of Hadoop, not just for people who are used to using Java and using Hadoop, but also our .NET customer base, which is very large. So you'll see again through the demo, we are unlocking .NET and also unlocking Windows for our customers who want to use Hadoop. So where's HD Insight running? We have data centers around the world. I've had this question a few times. If I'm in Europe, for example, if I'm in France, if I'm in Germany, and I need to have my data in the right location, I need to have it in Europe for regulatory reasons, for performance. Can I do that? Absolutely, you can do that. Again, we'll see how that's done. But today we're in more than 13 data centers, and that's growing, I won't say daily, but on a regular rate. We are in China, we are in Europe, we are in North and South America. So you'll see this map continue to grow. And this is a subset of Azure. Azure has many more data centers, but we're rolling out HD Insight by region. So Microsoft does, in fact, love Hadoop. Again, this hopefully as we go through this, your eyebrows will lower and you won't be surprised by that statement as much. But we have done a lot of work. There's been thousands of engineering hours spent on code that we've contributed to Hadoop. You'll notice a number there, 30,000 plus lines of contribution. We've been very active in the Tez work and in Stinger. We've been active, of course, on getting Hadoop to run on Windows. We've been contributing to all these Hadoop versions 2.2, 2.4, 2.6. We've been focusing a lot on this query execution speed up. So the work on Tez and Stinger, the work on query speed up, we've been able to see things up to 100 times performance improvement in certain kinds of queries. So these are some areas that we're doing research, but also areas where we're contributing to open source. And you'll see more of this. This is, in the last couple of years, you've just seen us start into this space. You'll see a lot more in terms of open source contribution, as well as leveraging the Hadoop ecosystem of tools and products. So I'll just go very, very quickly through the things you can get on HD Insight. So absolutely, Hive is sort of table stakes, being able to do Hive and Pig. And we support every HD Insight cluster that you provision on Azure will have automatically Hive support. We have a little chart on the bottom there to show some of the speed up that we've been working on with the different HDP, the Hortonworks stacks evolution, as well as the work that we've been doing that I mentioned around Stinger and Tez. So we continue to try and push the envelope of getting good performance out of both the Hadoop distribution, but also our implementation of it in Azure. We do support HBase, of course, so you can have your NoSQL database set up, and you can create that as a standalone cluster, as a standalone service within Azure. And of course, you can access those HBase tables from other parts of the Hadoop ecosystem on premises or within Azure. And very importantly, and more recently, our support for Storm has rolled out. I'll show you a little bit of this in a moment. We have a lot of people interested in stream analytics and in being able to use Storm. So we try and make that as simple as possible. Again, as I mentioned, we're trying to give people more choices. So in the case of Storm, we've developed a set of .NET libraries so that you can actually author bolts and spouts in C# as well as Java. And then you can deploy those very simply to our cloud-based cluster for Storm and have running topologies that emit information. So here, I won't go through these diagrams in detail because I trust that a lot of you have some familiarity with Storm. If you're interested in more detail about this, you can come to our booth afterwards, and I'll be happy to talk through this with you. We also use Visual Studio, which I'll show you momentarily, to help the developer story. And Storm in particular becomes quite easy when you go into the Visual Studio environment, both in terms of developing it and deploying it. And we do run on Linux, so this is one of the things that I've had people ask me, really, are you serious? You're really running on Linux? So you have a choice. Again, you can spin up an HD Insight cluster with Windows or Linux as the OS on Azure. You have a choice. And we work with DocumentDB. DocumentDB is a Microsoft NoSQL solution, so we have customers who want to use a non-Hadoop platform for NoSQL, so you can do that. And I put this in here because I want to point out that there are other non-Hadoop things within Azure, including DocumentDB, including event hubs, which we allow you or which we enable you to use with the Hadoop family of services that we're offering on Azure. So we're trying to make as much integration as possible. Of course, machine learning is another area which I'm not going to cover today, but Microsoft has a number of machine learning offerings in the cloud, and those will also work with, at a minimum, the data sets that you generate through Hadoop, but also more directly with some of the Hadoop components. This is the Visual Studio, which I'll show you in a moment, so I won't really talk through this one. And let's see, let's switch to a quick demo just to show you some of these concepts. Okay. So first of all, I'll just go to, this is the Azure portal, and I hope that you can see that. I'll zoom in on some parts as we go, so don't worry about that. But this is basically the Microsoft Azure portal that you'll see once you've signed up to use Azure. And you'll notice that there's lots of stuff here. You know, you can set up your websites, you can do your virtual machines and SQL databases, all the basic infrastructure services that you might expect from a cloud platform. And if I go down a little bit more, you'll notice that we have the HD Insight showing up here. So when you start, you can simply go to the new button here, go Data Services, HD Insight, and choose. Do I want a sort of a plain Hadoop cluster? Do I want an HBase space to do my HBase work? Do I want to set up Storm? We're doing a preview of Spark. Sorry, this is small again, so let me see if I can. Yeah, you can do Storm, Spark, and Hadoop on Linux. It says not available because you have to sign up for preview at the moment. It's in the preview state, but it is working, it is available. But if I simply click now on Hadoop, I can come here and give this a name and choose the number of nodes that I would like to have. And you can change this number later. And I choose an Azure subscription, so all of the Azure payment system and billing is based on subscriptions. So I can choose a subscription it's going to be a part of. I can provide a password for administration purposes for when I later come into this portal. Oops, I didn't get that right. And then I can also choose a storage account to associate with this. So I have a bunch of storage accounts I'd created already. And the storage account is what makes this associated with a particular region. So when you set up your storage account, which I didn't show you that step, you can choose this is Western Europe, you can choose in the central US, you can do all those things. And I can, I'm still not getting my passwords correct. Sorry about that. This is poor typing on my part. All right. So when I hit this to create, it'll start to do that. You'll notice this little graphic on the bottom, this green stripes that are actually animated, and it's saying yes, that I'm working on creating that cluster for you. It'll take a few minutes as it goes out and gets the resources and sets them up. And this cluster, once it's created, it'll look like other things that I have here. So you'll notice, for example, I already have a couple that I've created. One that's a Hadoop cluster, one that's a Storm cluster. So these are now machines, VMs in the cloud. They have the HDP stack already installed on them. They're all configured and ready to go. And they have storage in Azure Blob Storage. So whatever you create, any files you create, any output you create, will all be in cloud storage. So basically, there's nothing else you have to do at this point. These are ready. Could be an 8-node cluster. And I showed you the fast case. If you want to customize, if you want to say I need to set special parameters, I need to pick different kinds of VMs, like more powerful VMs with more memory, you can do all of those things. I'm just not showing that right now for simplicity's sake. And you'll notice that in terms of location, some are in Western Europe, some are in West US, again, based on whatever I chose. So this is and there's more that we can do here. Again, this is not a comprehensive demo, so I'm not going to show you all the features here. But you can kind of go into some of these clusters, and you'll get some information about how to get started. You can also do monitoring and dashboards, which will show you some information about these clusters. But what I'd like to switch to at this point is to go to the Visual Studio side, because we feel that the development aspect of Hadoop or working with big data is very important. So we paid a fair amount of investment in making it easier to develop queries, to develop code that you'll use to process your big data. So here I'm showing you Visual Studio, which again, a lot of our enterprise customers are using, and with now the Visual Studio Community Edition, which is a free edition. Any of you can go ahead and download that. And these Azure tools, the Azure Cloud tools, which include the HD Insight tooling, are all downloadable. You can be set up in a few minutes and start to use the same environment. So in here, you'll see that we have a view of the Azure services that are available. There's a Server Explorer. So again, you'll notice that cloud services, notification hubs, SQL databases, they're all here, and specifically HD Insight. So let me just expand that a little bit. So I have actually lots of, because I'm part of subscriptions that are shared with some of my colleagues, you'll notice there's a very long list of clusters I have here. Probably as you get started, it'll be much easier to manage, shorter list. But if I pick out, for example, one I was showing you earlier, which was the one that I had created for this event, I can click through here and basically find out the Hive databases that I have here. That I can navigate a storage account. I'll just expand this a little bit so that you can see. So here I have a basic cluster. I have some sample databases in here, sample Hive databases. I can basically navigate through and do a lot of understanding of what I have. Then we also can come here. Here it says Start New Project. If I go for a new project, I have some existing templates that I can use to create a Hive application, a Storm application, and we have some sample code. So all the ones that say Hive sample, Storm sample, if you click them, it'll load a project template for you, but it'll also put some code and some comments to help you get started. So I can hit click here. I can do that, but I've already created one, so let me just show you what I have. I actually took one of the sample ones. So if I look in the Solution Explorer, there's a project. There's a couple of Hive query language files, the sensor data analysis, the weblog analysis. And if I open the weblog analysis one, and we'll just collapse this, make it easier to see, you'll see there's some, as I said, this was one of our sample tutorials. There's a bunch of Hive code in here. So we have what you would expect from Visual Studio IDE. We have IntelliSense, so it's helping me to actually construct my Hive language query here. I'm saying, now I'm going to say select star from a table that was created. So as soon as I hit space, it gives me a list of suggestions. I'm sorry, it's a little bit small. But it'll actually give me a set of choices from both things that I have already put in the script, like web logs. I defined a table called web logs here, and it's showing up here. I also had some stuff in my already existing in the cluster, like this Hive sample table, so that's also here. So we're looking both into your current script and into your cloud resources to give you ideas or to help you construct your code. So if I say, I want the Hive sample table, and I can say where, as I start to type now, it's showing me even the fields, individual fields from, or columns I should say, from this table. So these are, for people who are used to using Visual Studio, this is very much fits the template of how things work. But I just want to point out we've enabled this for Hive, we've enabled this for Storm, so you can do this quite simply. And then when you're ready, you can just say, you can come here, right click, and say I'm going to submit this script. And you'll see a little progress bar at the bottom that says this is going to go to the cloud. And you'll notice here that I got a sort of a job summary. So it says, yes, I've submitted this thing called weblog analysis. Right now it's initializing. And you can refresh here as time goes by. Or you can take a look. You can come back here and say, you know what, I just want to see in this cluster, I want to view all the Hive jobs that are happening. So this will give you actual view of whatever is running currently and has been running before in this cluster. So we're making it easier and easier for you to just stay in the IDE and deal with your code. I have some stuff here that completed, some stuff that failed. If I click on some of these and pull up the job summary for them, you'll notice that I can also, now that they're finished, you have these links where you can go to look at the query, look at the output, look at the logs, and even go and collect yarn logs from the various nodes in the cluster, and we'll go do the collection, do the integration of those logs and deliver them to you. So a lot of this stuff, if you were doing it from the command line, from traditional sources, you have to go and find individual machines in your cluster. You have to remote desktop to them, FTP them, tell them to go find these logs, go collect them, get them onto your machine. We're making that a sort of one-click thing for you. So let me just this was Hive, let me just switch over to Storm for a second. So if I come here, you'll notice that I have things with little alphans, which are just Hadoop clusters, things with this H, which are H-based clusters, and things with this lightning bolt, which are Storm clusters. So I also have a Storm cluster that I've created for this particular conference. And if I look over here, now I'm looking at a Storm project. So as you might expect, this is actually going to be a quick demo of setting up a Twitter feed, streaming it in, processing it, doing something, including filtering some tweets and sending them to a website. So this project, you'll notice has, let me just expand some of this. It has some bolts, it has some spouts, it has a bunch of references. So in terms of references, we're using this tweet envy library for doing handling the Twitter feeds and parsing them, so I didn't write all that myself. But I have a bunch of bolts and spouts that are, as you notice, written in C#. So let me just go into one of those so you can see for example, the Twitter spout. So here, you'll notice traditional C# .NET kind of coding. I can come down here and, for example, change something about what I want to filter for. So right now it's filtering for Microsoft, just something that does have a lot of tweets so we can see it. And if I go to Twitter stream project here and say submit, it lets me pick whichever cluster I want. I might want to test this out on a small cluster, I want to run it on a bigger cluster. I have choices there. I say submit, and it'll start to build it and generate the zip package, and it's going to upload this, submit this to my cluster, and get the topology to start running. So I won't, actually here it says submitting topology is going to do this. And once that's running, again, I can let me just go to, because I have some running ones already, I can go back to this cluster, I can say view Storm topologies, and I get, just like I did view jobs before, I can kind of get a view of topologies that I have running in this cluster. I can kind of get an idea of, how long it's been uptime. This is the one I just submitted, so it's been up for 3 seconds. You see in the upper right, it hasn't really emitted much, but I did have one running before. If I click that one, you'll be able to see that this one has been running for an hour, 37 minutes, so just earlier in the day. It's been emitting events, and just to prove that I'm not making this up, I should be able to go here. So as I mentioned, the topology here was reading stuff in from Twitter, doing some filtering and processing, writing some stuff to database, which I didn't show you, and then sending some of those things to a website. So I'll just show you that website here. It's a very simple one that just starts to, here we go. This is actually the running topology emitting tweets that have the word Microsoft in them, keeping a little running count of how many tweets it's seen. So hopefully the feeling you get from this, although it was very rapid, is that getting set up with Hive, with Storm, with HBase in Azure is quite simple. On the one hand, you have the configuration and setup of clusters, which can happen within minutes. On the other hand, you have a development experience, which definitely unlocks a lot of debugging and runtime tools, and also enables .NET in addition to Java. Of course, Java right now, you are not going to do that in Visual Studio, but you're completely free to develop Java using your existing tools and submit them to the same Azure clusters, and they will run in the same way, for example, for Storm, Spouts, and Bolts. So let me go back to here. So as promised, part of this talk was to be about what are some of the applications we're seeing. So it's nice for me to say we have all of this capability. It's nice for me to say that it's a good idea to put Hadoop in the cloud, but are people actually doing it? Again, I've had this question live in the last couple of days. Do you have really customers, or do you just have proof of concept? What do you have? So we've had HD Insight in the market since late 2013. So that's a year and a half or so. This is a list, and there's actually a second page to this, without customer names. So these are so each line here is at least one customer. In some cases, we've combined 2 or 3 customers. I'll go back to the previous one. Just to give you an idea of the industries we're getting customers from, as well as some of the use cases and types of data. I'll go to another slide where I try and summarize this a little bit. But the point being that it's quite broad. The kind of cases you might expect, like healthcare, we've talked about that in multiple sessions. Power and utilities, we had British Gas people speaking yesterday in this conference. Digital marketing and advertising, quite obvious cases, and some more like entertainment and gaming, at least for me, was not one of my things that jumped into mind when I got into big data earlier on, but we're seeing a lot of telemetry and analysis of gameplay for online games, but also for, I can say this one, the Xbox team, our own Microsoft Xbox, absolutely uses a lot of big data analysis to understand gameplay, both for online games and also for console games. And you'll notice that so actually let me just go to this slide. So I think a way for us to think about, at least for this brief session, I'm not trying to give a sort of a academic breakdown of what kinds of patterns there are. I'm just basing this on customers we've seen. So this is not to say the future will be the same as the present. But we are seeing definitely that at least 2 axes we can think about. One is the type of data, and this is not a surprise. So definitely there's unstructured or mixed structured data that's being heavily pulled upon, like social data, server logs, things that are more semi-structured, click streams. A lot of IoT cases, of course, have sensor data. I think that what I would say on this side is I've put mixed at the beginning, but really most of the use cases that we observe are mixed data types. There's a mix of unstructured, semi-structured, and traditional structured data being pulled in together. And then the types of analysis, I've picked out 4 large categories here based on our observation. So definitely product development. So I would put the Xbox guys, for example, in this category where they're trying to understand what features, what kind of gameplay really works for the customer and drive future roadmap based on that. We have another one, which is, I think, the one we most often think about, customer understanding. So whether it's segmentation or engagement adoption metrics. And then marketing, which was broadly where I would put a lot of the sentiment analysis. And of course, I'm putting the recommendation systems in there as well. And then there's a small but notable set of scientific use cases here in terms of trend discovery or, analysis of large populations of data, especially in the medical field, healthcare field. So I picked out a couple to look at here in a little bit more detail. So again, these are real cases with names removed just because we don't have the permission of these particular customers to share their details or to share the full case. But this one is for a computer manufacturer. This is a name you would have heard of. You would know if I mentioned it. And their challenge, of course, is that they have an online store where people are buying stuff. And they want to both understand the customer behavior and they want to increase the conversion rate from people just visiting the site to actually getting purchases. So very common case that you can imagine for lots of retailers. They did choose Azure. They went head-to-head with Amazon and chose Azure as a company direction. And then based on that, they were using HD Insight. They used HBase. I'll show you a little sort of high-level architecture in the next slide. But the point is that they want to basically look at click streams, look at IP addresses for customers. They want to build a profile and show recommendations. They also want to do a bunch of things around targeted advertising and abandoned carts. So when people come and go to a certain point and then they give up, they want to go and pull those people back in somehow and sort of say, you almost made it. What can we do to help you actually buy something? So let me just show you a diagram here. Again, it's probably a little bit small for people at the back, but I'll explain it. So this middle row is stuff that's not in Azure. This is stuff that I'll broadly call on-premises. It could be that it's also on another cloud or another platform, but it's not in Azure, being the point. This is back to my claim that Microsoft understands and really supports this hybrid kind of methodology. But Microsoft aside, the point is that people will be using Omniture to manage their weblogs. They will be having their own .com, their own portal, their own website, and probably some email system, which is what the customer has here. And there's two parts here. There's one part where Azure is being used for the recommendation engine. So here, Event Hub is the tool being used to collect and forward events in a reliable way from all of these sites that the customer has, so from the website, server logs, from the Omniture web logs, and feed this into ASA, which is the Azure Stream Analytics. So it's basically a Storm-like construct where you can do streaming analytics and feed into or connect to the Azure machine learning system. So this side is all about figuring out, first of all, this is the recommendation piece. So the machine learning is for training the recommendations. And then, of course, there's a runtime piece where the stream analytics are being compared to what you've trained for, the model you've trained for machine learning, and you're spitting out recommendations directly back to the website. On the top side, this is where the email targeting is coming in, and this is where the Hadoop tools are being used. So here again, we're taking the web logs and the product catalog. These are going into blob storage in Azure. And then they are running HD Insight clusters and running Hadoop jobs on a weekly and monthly basis. Again, there's a piece here for sending training data to another machine learning system or another machine learning instance, figuring out, again, a model for how to identify abandoned carts, how to identify various cases where there are high-value targets for email. And then that information is being stored in HBase, as well as going through some VM, some custom code that they've developed to send it to their email server and trigger a workflow from the email server side to actually send out the targeting email. So again, the reason I pulled this one out is because there is so much in cloud and on-premise or cross-cloud interaction happening here. So you can see that both of these have been sort of added on top of something that exists already. The other one that I picked out here is one that's focused more on an IoT kind of situation with sensor data and analytics on that sensor data. So this is for an industrial automation company that works with oil and gas. This is a bunch of point of sales, basically pumps. These are unattended natural gas distribution sites. So they're refueling stations in the US. They're unmanned. So they have to be monitored on a continuous basis, monitored for upcoming failures. So you'll notice here it mentions there's lots of data points, but includes temperature, pressure, vibration, so on. So again, they chose Azure HD Insight and Azure Data Factory, which is our orchestration mechanism for Azure. And they use SQL databases, they use machine learning. The point is to have dashboards to look for anomalies, to look for proactive maintenance opportunities. And the system looks a little bit simpler here. But basically, these are pictures of the pumps. These pumps are so this collection point here, the pumps and their individual data sets being collected and aggregated at sort of intermediate hubs. This is something that's being done outside of Azure. And again, that's a common use case that for large distributed sensor data systems like this, there would have to be some intermediate collection points. And again, you can use Azure to build some of that, because with Azure's multi-geographic installation, there's lots of opportunities to build custom code or build aggregation points, still using Azure. But finally, we're using this data is being fed into Azure blobs. There's also a separate stream for mobile notifications. There's a hub that they built for generating mobile notifications for the operations team and going to real-time notification on mobile devices. But the main part is that these Azure blobs are getting filled up with this IoT data, and they're using Azure Data Factory to sequence a set of HD Insight jobs, a set of Hive and Pig scripts and code that need to work together to analyze and aggregate this information. And then they're writing this into Azure SQL DB. So this kind of flow of having a large set of data collected and sub-aggregated and finally put into, sorry, not sub-aggregated, collected at multiple intermediate data points, but all of it being written to the blob. So nothing is getting dropped here. Then getting processed into more aggregated data sets, some of which are put into a relational database. This is a very common pattern, which we also see very much in our internal big data use cases within Microsoft. And then that SQL database is used with Power BI, could be also used with Excel, with any number of BI tools that already exist to do dashboards, to do reports. So this is the basic setup that they have. And this is the starting point. They're operationalizing this into having more devices, sort of larger set of fueling stations to be supported. Plus, usually we see that there's a starting set of dashboards and reports that people start with, and then as they discover what data they have and what kind of insights they're interested in, those will grow quite quickly. So these are two that I picked out. There's of course more of them, and if you take a look, if you're interested in the booth downstairs, we have a running set of demos with the Power BI view of data, like the analysis tools that we have. We can show you a little bit more about HD Insight. And as I mentioned, there's many more sort of customer cases we didn't have time to get through right now. So that's, we have about 90 seconds left in this time. So they said that we could have questions. So 90 seconds. So if someone does have a question, I'm more than happy to answer that for you. Otherwise, as I said, we have a full team of people downstairs to help give you any information we can. So thank you for coming. Anybody want to brave a short question or? Yes, please.
So the data is on blobs, you say, but the accessing of the data on the cloud, is that never been a problem, or is it because we have now Hadoop on bricks hardware, and this is all about cloud. Is accessing the data on the cloud, isn't that keeping down the performance of the cluster? Or?
So are you talking about accessing the blob store from a cluster within your premises, or within the HD Insight cluster? Because with HD Insight, it's the blob storage is also in Azure. The HD Insight nodes are running on Azure, so it's all co-located, or it's all within the same domain, same infrastructure. So we don't have a problem with that. Like that doesn't seem to be a performance issue. And the blob is sort of the fundamental Azure storage mechanism. We build on top of that other capabilities. So the HBase, the Hive table, all of that is using the blob as kind of like directories or a file system, and adding stuff on top to make it look like a normal file system to you. So no, we haven't. We can talk more offline if maybe I'm missing something about your question, but generally this has been working well. It's not a problem. All right. Perfect. So thank you for that question, and thank you everybody for coming to the session.